Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi everyone, welcome back to this dynamic programming series. Very happy to see you all here. And can I just get a quick confirmation if my voice is clearly audible? So, hi Naikaj, hi Kamlesh. I hope all of you are doing well. And I will just share my screen as well. Okay. Thank you, Kamlesh, Rishabh, and Himanshu for the confirmation. All right, I am audible. Okay. Everything good from my side? All right, it seems so. So, welcome everyone. This is our days. Okay. So, welcome everyone. This is our day 6 of TP, day 6, and we are covering dynamic programming. Let's just wait for a couple more minutes, all right, so that rest of our friends can also join us. And till now, let me just do a brief recapitulation of what we have done. So, till now, what we have done is we have covered knapsack concept and the problems based on it, and then we have covered LCS concept and the problems based on it, and today we are going to do some practice questions. Okay, so in the yesterday session I have assigned 3 homework questions. So all right, before rest of our participants join, so for those who have already joined, can please let me know how many of you have done those questions, the 3 questions that we are going to discuss today. No responses yet. All right, everyone, I'm waiting for all of you to respond to this. How many of you have done the previous session's questions? So, some of the people that I see here, that is Naikaj and Himanshu and Rishabh, I guess, as well, you were in the previous sessions, right? So, I hope all of you have done the assignment. And even if not, then there is no issue. We are here to help you out with those questions. this is going to be our practice session. Okay, that's great, Rishabh. You have solved 2 questions. Okay, guys, so let's get started. Today, in these practice session, what we are going to do is we will be covering 3 questions. All right, we are going to take 3 questions that are based on the concept of DP. 3 questions. That's great, Himanshu. So let's just once discuss what there is approach that is from my side, and then if there is some other approach that you have used for solving the questions, then you can write it down in the chat section. Okay. So all right, 3 questions that we are going to discuss today that are based on DP. So the first question that we are going to do is count ways to reach an H stair. Okay. All right. So let's get started. Let me write down the questions once again. Count ways to reach and stair. Okay. All right, guys. So how many of you are here who have solved this question? Feel completely free, even if you haven't solved this question. If you were having some problems in solving these questions, there is completely no any issue. We are here to help you out with it. Okay. So the question statement reads as, we have to count the number of ways to reach the nth stair. Okay. Now let me discuss about the input and output that we have. So input that is given to you, that will be an integer value. Let us say it is 4, and the output that will be given to you, output that you need to give is the total number of ways. So output in this case, like let us say if there are 4 number of stairs. Okay. Now you can reach to the 4th stair in total 5 ways. All right, there are 5 ways to reach the 4th stair. What are those ways? You can take either 1 or 2 stairs. All right. Okay, is there some issue with my screen sharing? Just a second. Okay. So we need to find, let me write down. Okay. Count ways to reach nth stair. All right. So in one step, what you can do is you can either take 1 step or 2 step at a time, right? So when we need to reach to 4, what you can do is either you can have 1 plus 1 plus 1 plus 1, right? Either you can have 2 plus 2, or you can have 2 plus 1 plus 1. Okay. Or you can have, what are the steps that you can take here is 1 plus 2 plus 1. Okay, this can be one of the method, and the other method that you can take is 1 plus 1 plus 2. All right, so in total what we have here is we have 5 number of ways. Okay, so in the input an integer value is given to you, and in the output you need to print that in how many ways you can climb, you can reach to this total value. Okay, by using only 1 and 2. That is the thing, you should keep this in mind. So yeah, good evening, next. So all right, so we have answers here if n is less than 0. All right, Nikas, I think you are trying to discuss about the base case, right? And then n plus 1 base, right? And also in this question there is one thing, that order does not matter. Order does matter, right? So keep this in mind. That's why here we have considered this as 2 different cases. This 211 is considered as different from 121, and this is considered as different from 112. In all these 3 cases, what we are having, 2-1 and 1-2, right? But still they have been considered as different. Why different? Because order matters. Okay. All right. All right, Nikaj. So Nikaj has done the assessment and he has shared his approach with us. That is, if n is less than 0, we will be returning 0, and else we are returning the function n minus 1 plus n minus 2 plus 1. All right. So Nikesh, can you please explain the logic behind adding +1? All right, and also for the base case, okay, so let's just analyze the code that is given by Nikesh here. For the base case, you have here written if n is less than 0, right? So actually, if you will look at the constraints of the question, so the constraints are given as n is starting from 1 only, right? So the least value of n that you can have is 1. And as we have discussed in the previous session, whenever you are discussing about the base case, you need to consider the least valid input, right? Or whatever is the least like the lowest value that you can give to your input integer, right? So in this case, the least value that you can give to n is 1. So you need to write the base case for n is equal to 1 or less than 1, right? So the base case can be something, if n is less than is equal to 1, then you can simply return n, right? That can be your base case. All right. So is everyone clear about this base case? Is if there are two base cases, if n is 0, return 1. If n is less than 0, return 0. Great, Nikos. This code now seems correct. Return f fun of n minus 1 plus function of n minus 2, right? All right. So if why two base cases? I mean, the constraints. If you will look at the constraints of the questions, right? So in that it is written that n is always greater than is equal to 1. Sorry, n is always greater than is equal to 1. Okay. So I guess we can remove this n is less than 0, and instead of that you can write this, that if n is less than is equal to 1, you can simply return 1. Sorry, that will not be n. You can simply return 1. I think that this can be the correct base case. Please everyone let me know in the chat section, because if n goes negative then it not counts. Okay, so if n is going negative. All right, so what do you mean by base case here? That's a good question, I guess, that if n is going negative. But do you think n is really, it can go negative? Because here we have written that if in any case, see, base case means what? Recursion will stop there. All right, so if at any point n will come less than 1, all right, it can be either 0 or 1, right? So in that case you will be returning 1. So your recursion, the code that you have written, that will stop then and there, right? So there is no any scope of n turning out into a negative integer, right? So I think we can safely use this statement as our base case, that if n is less than is equal to 1, then we will be simply returning n, simply returning 1. What is the meaning of base case here, right? Let me just discuss few things about base case. Base case means, yeah, that's great, but just let me discuss few things about base case. All right, so base case means that recursive code will stop, right? Why we say that base case is important for recursive code? Because recursive code then will keep on processing in the endless loop. All right, if there will be no base case, so base case does what? It stop our recursion, right? So once if you will reach to this point when n is less than is equal to 1, you will simply return 1, right? So you will not be processing n further that, right? So if you are not processing n before post that getting less than 1, that could be either 0 or 1, so there are no any chances that n is going to turn into negative, right? So what you can do for base cases, you can simply write if n is less than is equal to 1. So always look for the constraints that you have, and on the basis of that constraint, find out that what is the least valid input that you can provide, right? So on the basis of least valid input, find your base case. Okay, so this I have discussed in the previous session as well, so let me just write it down again. On the basis of least valid input, find base case. Cool. So this is going to be our logic for all the recursive code that we write. All right, so our base case is clear. Now, basically, as Naikaj mentioned, he mentioned it very correct. What we are going to do is we will simply return function of n minus 1 plus function of n minus 2. Cool? Because we can take only one or two steps at a time. Now, this will result in a recursive code, right? Can any one of you tell me in the chat section that what this function is similar to? We have done this same kind of recursion. This is just a very much similar to a pattern. And what is that pattern? Returning these two functions, one n minus 1 and one n minus 2. Okay, so what is this pattern? When do we do this thing that we take the sum of the previous two numbers to get the third number? Like a plus b, we are getting c, and then we are exactly, that is Fibonacci. All right, so is everyone in the chat section clear about this? That this is a Fibonacci sequence? Because basically what we are doing is we are finding the sum of in how many ways we can, like, let us say this is your stair, okay, nth stair. So basically what you are doing is you are finding the ways in how either you can come here after covering two steps at a time, right, or either you can come here after covering one step at a time, right? So what you need to do is basically you need to find that in how many ways you can come here by covering one step at a time, and in how many ways you can come here by covering two steps at a time, right? And then once you will add it, good evening Miral. So when once you will add it, you will be finally getting the answer to reach the nth stair. Cool. So basically this is nothing, this count ways to reach nth stair, this is nothing but just a Fibonacci code. Basically a Fibonacci sequence, right? Okay, so everyone please give me a thumbs up if I'm able to clarify my concept, and if you are all able to, justify this thing, justify the logic that why this is a Fibonacci sequence. Just give me a quick thumbs up or +1 in the chat section so that we can proceed ahead. Thank you, Miral. Thanks, Rishabh. If n is 3, then number of ways that we can have is 3. Where like either it can be 2 plus 1, or it can be 1 plus 2, or it can be 1 plus 1 plus 1. Right? I think these are the 3 ways that comes in my mind. Alright, so as I can see, few +1 in the chat section. So let me just show you the code for this question, and then it will be more clearer to you. Alright, are you guys able to see the code? So basically what I have done here is I have written the code for the Fibonacci sequence only, where the first two values that I have taken are 1 and 1 only, right? So that's how we start our Fibonacci, right? And then you can just simply write the code for Fibonacci, and why I have written here mod to avoid the integer overflow, okay? Yes, Nikals, you are pretty much correct about this. Okay, so yeah, as we can see, it is very nice to see that all of you are able to devise the correct logic, and all of you are able to conclude the final answers of questions. Yes, exactly. That is what we write in Fibonacci as well. But actually, like, see, in the like in this question, you need to follow the code for Fibonacci sequence, because if you will do this array of I minus 1 plus array of I minus 2, then in that case you will not be getting the correct answer here. Why? Because order matters. Okay, you can use this code when order is not mentioned, like there is no any effect of order, but in this case order is order, just give me a second. Yeah, so here it is written that order does matter, right? So if you will use 1 to 1, then it will be considered different than 2 1 1, right? So that's why what we need to do is you need to find out the total number of ways, and that's why you need to use this Fibonacci sequence code. Okay, when order is not mattering, in that case you can use this code that you have written. So basically you just need to find out the sum of the two previous integers a and b, and this is just a Fibonacci code. I just hope all of you are clear with this code. So please let me know that in the chat section itself if we are good to go to our next question. Thanks, Needle, for the confirmation. Let's just wait for a few more confirmations. Okay, Rishabh, mod is used to avoid the integer overflow because as you can see, you are adding two integers, and it might happen that in larger cases, you can exceed the maximum integer value, that is 2 raised to the power 31, that can be reached. Alright, so to avoid that, we are using this mod. Because as you can see, we want our answer like this: a is integer, b is integer, but that is not, and temp is an integer as well, right? So that's why you need to have mod, and using mod is anyways a good practice if you want to avoid overflows. Yep, our space is constant. That's correct, Michaels. All right, so I think we have a green signal for this question. And okay, so let's just now move to our next question. If there is any queries, like, please feel free to drop it in the chat section. For now, I am thinking that we are good to go to our next question. All right, so I will just share the next question with you all. Just a second. Okay. So let me just first ask you, how many of you have solved this question? Many of you have heard this question name, quite a famous question, right? Stickler thief. Or this question can be reframed as maximum sum of array when no two adjacent elements can be taken. Or this question is also famously titled as house robber. So all of these are the same thing. Okay, so none of you have solved this question? Alright, let's just write it as house robbery. So how many of you have solved this question? Alright guys, no issues. Let me just help you out with this question, okay? So basically the question statement reads is, what is happening here is, you have n number of houses, okay? And there is certain amount of money that is stored in these houses, okay? Let us say a, b, c, that is the amount of money, okay? E, f, g. Now what is happening is, there is a robber, right? There is a thief, and he's having a bag with him, Okay. So what he tries to do is he wants to visit these houses, right? And he wants to collect money from these houses. Okay. So that is and whenever he take out the money from the houses, whenever he choose that house to take some amount, so whatever he's doing, there is a rule that he follows, and that rule is, if he will, let us say he's selecting this house to rob money. Okay. So if he's selecting this house, then what he will do, he will not select this house and this house. Okay. Adjacent elements are not selected, he can only select D after it, right? Let us say if he has selected this house number C, then he house with the value C, then what he can do is this B and D can't be selected. All right, he's not going to select the house with adjacent elements, right? Adjacent houses are not selected. So by following this rule, what you need to do is you need to find out that which houses he should select so that he can have a maximum amount of money with him, right? So let me just write down an example here. Let us say we have 5, 5, 10, 100, 10, 5. Okay. So let us say this is the n number of houses that are lined up, and this is the thief, and he is trying to loot money from these houses, right? Is he looking like a thief? Yeah. So he's trying to loot money from these houses, right? So now what is the most optimal strategy that he can follow is he can take money from, what we have to do, you have to help this thief basically, so that he can have the maximum amount of money with him. Let us say if he's having this house, so what he can do is he can select this house and this house, right? So in this way, what is the total amount of money that he will have is, that is 110. Okay. So this is the thing, and also there can be this thing that maybe he is not selecting this 100, right? The approach that you have said, Nikes, that is not exactly correct. I mean, if you are talking about only to take some of the alternate elements, then it might happen that, let us say if you have taken some of alternate elements, okay, A, B, C, D, E, F, G. All right. Video got paused. Is this case with everyone? Okay. So let us say we have this houses 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7. Okay. So as Nikas mentioned, what we are trying to do is, what we can do is simply we can select some of this house, this house, this house, and this house, right? And then the second option that we have is to rob this house, and this house. All right. So Nikas, can this be the case? I want you to answer one thing. Can't we do this thing? Let us say if you have selected B, so it might happen that you are not selecting C, and when you select D you get the maximum value, right? This can be the case. Like it can happen na, that either after selecting B and C, like let us say if B is having 50, if C is having 10, and if D is having 100, then what you would prefer selecting? You would prefer selecting C, or you would prefer selecting D? Okay, so you can't just go for taking the sum of alternate elements, right? You need to have the most optimal value. Okay. And most optimal value based on the rule, what is the rule that we are going to follow is that you can't take the sum of the adjacent elements, right? So is the question statement, yeah, exactly, you need to go for all the ways that you can have. Okay. So is this question statement clear to you all? And this is our theme. Okay, please let me know if the question statement is clear to you all. Yeah, question statement is clear. Exactly, Nikes, that's very correct. Take or not take. So basically, DB is all about choices that we need to make. So the array, I'm sorry. So the array that we had is 5, 5, 10, 100, 10, 5. So what is happening is that basically for each of the elements we are making the choice that whether we are going to add this element or not, right? So what you can do is, first of all, we will need to maintain an additional array for our help. Let us say this is the t array that we have maintained, right? 6, 1, 2, 3, 4, 5. Okay, so this is the t array that we have maintained and this is the array that we have, right? So what you need to do is basically, let us say if you are let's talk about this 100. Okay, so if you are having, and see what does this t store, maximum looted value till ith index. Okay, so this is the two arrays that we have on this array, and then we have created this additional array t. And what does this t is storing? It is storing the maximum looted value till ith index. Okay, so let me do the numbering as well. I'm sorry. Yeah, let me do the numbering as well. We have here 0, 1, 2, 3, 4, 5. Okay, so in this case what t will store at this point, t will store the maximum looted value till second index. Okay, at here it will store the maximum looted value till third index, like this. Okay, now tell me one thing, when you are iterating inside your array and when you are at this index, say 100. Okay, and let us say if you have you have two choices, either include or exclude. Right. Now tell me one thing, when you have included this 100, okay, let us say you have added this, let me make it thoda sa clear. Yeah. So whenever there is element, we have two choices to make, and those two choices are include or exclude. Okay. Now, you guys tell me one thing. I have decided to include the 100. Okay, that is, let us say my I is at that index. Okay, which is this index 0, 1, 2, 3. This is the third index. Let us say my array, the I is at third index. Okay, and I have included it. So if you have included this array of I, so tell me one thing. Can you uh, rob money from this house number 10? Or rather I should say the house that is numbered I minus 1. If you have looted house I, can you rob the amount from house number I minus 1? No. Okay, so everyone, are all of you clear about this thing? Exactly, that's correct, Nikels. We will not be including I plus 1 as well. But then what is happening here is that as we are traversing in this manner, so that's correct, we are not going to include I plus 1, but that thing will not be reflected in our code. All right, because we are traversing from left to right. So in any ways, we have not processed this I plus 1 element. So we are not going to include it in either way. Okay. And we have to rotate the array. Can you please tell me how that is exactly going to help us? Okay, so we have no as our answer. So basically, if you have added array of I, then you can't add the value that you have till I minus 2. See, in this t, the array that I have named as t, if this third index, like, okay, third you have added. Okay, so what will be the t I minus 1 will be containing? T I minus 1 will contain the maximum amount when I minus 1 is included, right? When the amount at I minus 1 is also included, right? So in this case, what we are doing is we are not including, we can't include the amount at I minus 1. So basically what you need to do is you need to amount that has been collected till I minus 2. So is this thing clear that in if you are including an element, then in that case, the sum that you can have is the current element plus the maximum amount that you have robbed till house number I minus 2, because you can't access the house I minus 1 because adjacent elements can't be accessed. Okay, so if you have I, then you can have I and I minus 2. Okay, so is this concept clear of inclusion? Give me a quick +1 or thumbs up in the chat section. All right, Ashutosh. So we are discussing this stickler thief question, and in that question, basically the concept is you can't have adjacent elements, right? And without having adjacent elements, you need to find the maximum sum that you can get out of the array. Okay. So what is happening here is for every element, you are having two choices: either include that element or exclude that element. Okay. So what I have said is that when you are including the element, so basically what is the sum that you will get the current amount that is there in the ith index plus the maximum amount that have been robbed till I minus 2. Okay, why not I minus 1? Because adjacent values can't be added, right? That's why I minus 1 is not included. And so what we are doing is we are taking the amount from the current house and we are taking the maximum amount that we have collected till I minus 2 house. Okay, so that is for inclusion. Now let's just discuss about what is going to happen at exclusion. So let us say you have decided to not add this 100. Okay, so when you are not including I, at that time you can simply have this I minus 1 as the current maximum, right, for exclusion, because if I is not included then I minus 1 can be included. Okay, so is this concept of inclusion and exclusion clear to you all? How is it happening? We store the max sum in previous index or max value. In previous index, we are storing, yeah, that's correct. Like what we are doing is at t at I, will store maximum amount robbed till ith index. Okay, that is what t at ith is storing, and also it is taking this fact into consideration that ith house has been included as well. Okay. So, is this concept of inclusion and exclusion clear to you all? Please, if there is any confusion, feel free to ask. I would rather write it down again. If, okay, so there is an element, we need to make a choice. If you make a choice of inclusion, what you need to do is add the current house's amount plus the amount that you have robbed till I minus 2. Okay. And if you are doing exclusion, what you need to do is simply update the array with the maximum amount that you have looted till I minus 1. What is t? T is an array that we have created which stores maximum amount robbed till ith point, till ith index. Okay, all right. Is this thing clear to you? Inclusion, exclusion, and this t array and what it is exactly doing? Clear? Okay, so let me just share the code of this question. Yep, it's a tabulation method. So I will just. Is the code visible to you all? Thanks, Nikas, for the confirmation. And for everyone who have joined the session, I would request you all to please give a like on this video if you have liked this video and if it is of any help to you. And also, guys, we are starting our mock interview series again. So please do remember to watch that sessions as well. That will be very helpful for your interview preparations. So make sure that you are accessing those playlists for the mock interviews. Okay, so guys, this is the code for this maximum money that the thief can get. As you can see, we have created this new array, and then in T of this is the initialization that we have done. Of course, if you have only two houses, then what you will do, you will choose the maximum from two houses. Okay, and then what we are doing is we are just inside your array. What you are doing is you are just inserting the maximum of inclusion or exclusion. Okay, so this is basically in knapsack. If you remember, that is the same thing that we have done, either include the item or not include the item. So here is also the same thing. When you are including the item, the value of the item is also getting added, and when you are not including the item, the value is not getting added, right? And at the end of the iteration, you need to return the element present at the last index. Okay, so is this code clear to you all? All right, Ashutosh, to save some time, what we do is basically we have this pre-written code and then we kind of try to explain it. Please let me know if you have any confusion in these code. I would be very happy to help you. All right, thank you, Nikaj. And rest others, please give me a confirmation if this code is clear to you all. Okay, so let us now just move to our next question of the session. That is, thanks everyone for the confirmation. Share screen. Okay. This question that we are going to discuss now is longest increasing subsequence. Okay, so do we have anyone among us who have solved this question? No? All right. That's great, Nikaj. So I hope you have used the DP approach here as well. Let's just see what approach we have, and then if you have done anything different than this, you can share your code with us. Okay. All right. So we are going to discuss about longest increasing subsequence. Now, what is this exactly? Let me just first explain to you all the question statement. So the question statement is what you will be given is you will be given an array. Okay. Yeah. So in input, you are being given an array, right? Now what you need to do is you need in the output you need to print the length of longest increasing subsequence, right? So in this case, can you all tell me what is the longest increasing subsequence that we have is? And as much as I can notice in this question, we can have 5, we can have 7, or yeah, we can have 9. So the longest increasing subsequence that we have here is 579. So the maximum length that we are going to get is 3. That is going to be the answer to this question. Okay. So as it is a subsequence, so you can select the discontinuous integers. Okay. So I have selected 5, I have selected 7, I have selected 9. Right. So this is going to give me the longest increasing subsequence. And it is increasing. Means if you have an array say 555, the length of the longest increasing subsequence will be only 1, right? Because all of the elements are equal and we need the subsequence to be in increasing order, right? They must not be equal to each other. Cool. So this is what we have, and if it is okay, so the length of lis by default, all right, always there always be exist a longest increasing subsequence of length 1. Clear? Like whatever is an array, a single element can always form a part of lis. Cool. So length of the longest increasing subsequence is always going to be 1 in the worst case. So basically what I'm okay, is the input and output clear to all of you, what the question is exactly demanding from us? we need to find out the longest increasing subsequence. Okay. So let me know if this input and output is clear to you all. Okay. Thanks everyone for the confirmation. All right. So thank you, Nikesh. Thank you, Miral. So okay, let's just now move to the explanation part. How we are going to solve this question. Okay. See, the first thing that obviously that is very normal, that is brute force. And what is this brute force thing? As we need to find the longest increasing subsequence, so what you can do is try all the subsequences, right? You can write this recursive code. We have this recursive code to find out all the subsequences of an array. That is a recursive code. You can use that recursion to find out all the subsequences, and after finding out all the subsequences, just find out which is the longest increasing, right? So that can be one of the method, but that's not a good idea. We are here to discuss about the optimized approach. So let us just see what we can do for an optimized approach. Okay. So basically what we are going to do here is the array is 583791. Okay. Now we need to have the longest increasing subsequence. So for that, let us create an additional array with the name of longest increasing subsequence of size as equal to this 1 2 3 4 5 6 1 2 3 4 5 6. Okay. And initially what we can do is we can initialize it with the value 1. Okay, so what this long lis vector is going to store is, it is going to store length of lis till ith index. Okay, so we are going to take help of an additional vector, and here this additional array or additional vector, whatever it is, you can say it. Okay, so here we are going to name it as lis, and what it will store the length of the length of the longest increasing subsequence till this element, right? If you have added this element, okay, till ith index, when element at ith index is included. Okay, so this is what this is the function of the lis vector, lis array. See, I'm using this array and vector terms interchangeably. Okay, so now what you will need to do is, basically need to have two pointers, I and j, right? I pointer, you can keep it for the current element, and in the j pointer what you need to do is, like, just help me with this one thing. Okay, so let us say you have decided to form a subsequence starting from 5. Okay, longest increasing subsequence. So you will add 8 here as well in your subsequence. So if this is your longest increasing subsequence, will you add 3 in your LIS? If your subsequence is starting from 5 and the next element that you have added is 8, will you be adding 3 to your subsequence? Alright, I haven't changed the question name. None of you reminded me for that as well. All right, guys. Are you able to get my point? Like what the question I asked? I asked that if you have decided to create a subsequence with one of the elements 5, the other element as 8, will you add 3 to your this subsequence or not? Like till 5 8 it is fine, but are you going to add 3? Okay, so actually what we are going to do is we will not add 3. Why? Because if you will add 3, then it will no longer be increasing. We need to have longest increasing subsequence, right? Is my voice audible? Like just in case none of you have answered this question, so I kind of feel maybe is my voice audible, and also are all the concepts clear that I have explained till this far? At least please give me a confirmation for this so that we can proceed ahead. So my chat stuck. Okay, everyone. So I'm just proceeding ahead. If there is any issue that is from my side, or if there is any concept that you're not able to understand, please feel free to post it in the chat section. All right. So we are not going to add 3. Why we are not going to add 3? Because it will not form a part of longest increasing subsequence. Okay. So basically, how you have decided that you will not add 3 means if you are adding this current element or not, that depends on what is the previous element that you have added, right? So basically in this question we will need to have 2 pointers with us, right? That is, we are going to take I and j. So basically what they will point it as, I will point at the current element, okay, that we are iterating, and j will go from 0 to I, right? 0th index to ith index, and what it will guide us, it will tell us whether to add element at jth index or not. Okay, so it will tell us about this thing, that whether we need to add the element at jth index or not. Okay, and how will it tell us that? Only you can add it only if a of I is greater than a of j. Sorry, whether to add element at ith index. Okay, it will be j only. Sorry. Okay, so let us say if it is 5 8 and 3, you can't, you will not be able to add 3. Why? Because 3 is smaller than 8. Okay, you can only add the ith element if it is greater than the jth element that you are traversing inside your array. All right, so basically what I have said here is we are going to have 2 pointers here, I and j. What I will point at, I will point at the current element, okay, that we are working on, and j will traverse from 0 to I, okay, from 0 to less than I actually. J will traverse from 0 to less than I, and it will tell you that whether you need to add the element at jth index or not in your LIS. Okay, that is the work of these 2 pointers, and you can add the element at jth index only if the element at jth index is less than the element at ith index, right? So okay, is this concept clear to you all? Please let me know in the chat section. Is this concept clear? Whether if a of I is greater than a of j, only then we will be adding the element at jth index inside our LIS. Okay, it will be forming the part of our LIS. Okay, let's just proceed ahead. So the second concept that we are going to use here is, once you have added this element, okay, let us say you have added 5, 8 and 9, right? Or either you can do 5, 7 and 9. Okay, so once you have added this element, then you need to update the lis as well, because what is lis? It is the length of longest increasing subsequence till ith index. Okay, when element at ith index is included, right? So once you have, let us say you have added 5 here, so all right, the length of the longest increasing subsequence till this index will be 1 only. Now when you are coming to this point 8, so if you have added 8 to your lis, then what you will need to do is you will update this length to 2. So how we are updating this? What you will do is simply you will write it as lis of I. How you are going to replace it? You will replace it with lis of j plus 1, right? What is, if you have added element at jth index, then it means that the size of the subsequence has been increased by 1. Okay, so what you will need to do is, whatever is the size till jth index, simply add 1 to it, right? So the second concept that we are going to follow is lis of I. All right, Nikas, that's a very unique approach for this question. That's a binary approach. I mean, I was about to give this question in the assignment actually, to solve this question in a different way, but okay, you have already solved it in this way. That's correct. So, okay, lis of I is going to be lis till j plus 1. So, these are the two equations that are going to help you for this question. Okay, are these two concepts clear to you all? Please give me a thumbs up or plus 1 in the chat section. Thank you, Nits, for the confirmation, and rest others as well. All right, guys, are we clear for this question? Please give me a confirmation so that we can proceed. Yep. If you will look from the optimization side, then obviously it is more optimized code than DP. Okay, so I'm believing that all of you are very much clear for this question, and these two concepts are clear to you as well. So what I'm going to do now is I will just share the code of this question. Just give a moment. Okay. So yeah, this is the code to this question, and as mentioned, what we have done is we have created an additional array for storing the length of lis. All right, and then we are using these two pointers I and j. And once when you have updated your lis, what you need to do is you return the maximum element that is inside your lis. Okay, the maximum element will denote the maximum length that we have. All right. So this is the code for this question. If there is any doubt, anything, any difficulties in understanding the code or the concept, please drop it in the chat section. Disconnected as mean I have been disconnected. All right, guys. So I think we are good to proceed towards the end of this session. Like that was all about today's session. We discussed the three questions based on DB, and we discussed about the approaches that we can use. And also for this last question, there is another approach as well, that is without using DB, that has been already shared by Nikas. But I would like you all also to try for that different approach. And other than that, that was all about the today's session. If there is all right, can I go through the solution? Of course I can. So this thing, what I have done here is I have created a vector array. I have created an array of size n, and this LIS array, what this is doing is it is basically storing the maximum length that you have till ith index, okay? And taking into consideration that the ith element have been included. All right. So this is this LIS, and why it has been initialized with the value 1, because in any array that you will take, the length of the LIS will always be 1. Like there can be an LIS with the minimum value 1. Okay, that's why it has been initialized with 1. Now what I'm doing is first of all I'm starting my iteration. This iteration I'm doing in array elements, right? In the array that I have, I'm taking 2 pointers. Let me just show it to you in the okay. So basically, what I'm doing here is 2 pointers have been taken, I and j. So what will I do? I will keep on traversing through all the array elements, and how j will traverse? J will traverse from 0 to I. Okay, j is traversing from 0 to I, and now on the basis of that, what you will decide, that whether you are adding the element at jth index or not in your LIS. Okay, and how you are going to decide it? As you can see here, when you are iterating on this is the I pointer that will be iterating through the elements, and then j pointer that is iterating from 0 till the ith element. Now if the current element is greater than the element at the jth index, okay, so it means that it can form the part of the LIS, right? And also let us say that it has formed the part of LIS, and then after that you will check that if the li that the longest increasing subsequence till I, okay, if the length of this is smaller than the length of the longest increasing subsequence till jth index plus 1, then what you need to do is you need to simply update it. What I mean by here is, let us say if my array is 5, okay, just a second, let me see the example. 583791. Okay, let us suppose it is 583791. Okay, the size is 6. So this is my LIS, right? Initialized with 1. Now this is as it has already been taken into care, this first element. So now I'm starting from I is equal to 1. Okay, so value of j in the first iteration, I is 1 and j is 0, right? So if j is here, now tell me, is, and the condition that we are using is a of I must be greater than a of j. And if, all right, this is the condition that we are using. All right, so here now tell me, the is a of I greater than a of j? It is. Okay, so as it is greater than a of j, so what you will be doing is you need to update it as LIS of I will be whatever is the maximum value till LIS of j plus 1. Why plus 1? Because an element has been added. So when you will add an element, length will be increased, right? So here you can replace it with 2. Now you will come to this element. Okay, I will come here, j will start traversing from 5 and 8. All right, so is a of I greater than a of j? No, it is not happening for any of the cases, right? Let us now move to here. I is at 7. Is a of I, and my j is at here at 5. Okay, is a of I greater than a of j? In this case, yes. So for, okay, 0 1 2 3 4 5, 0 1 2 3 4 5. So at third index, what I'm going to do is I'm going to update it with the value 2, right? Whatever is the value of LIS of j plus 1, right? Now when j is coming here, for all of the cases that LIS of I is the a of I is not going to be greater than a of j, right? From j traversing from 1 to 3. Okay, it as 7 is greater than 3, but when you will update it, you will again get the value as 2, so it is of no use to update it. Let us now move to the next element, that is 9. So when I is at 9, j is starting from 0 again. So is a of I greater than a of j? Yes, it is. So what we are going to do is we are going to update it with 2. Why 2? How you are going to update is you are going to update it as lis of j plus 1. All right. Now j is at here. Is lis of is a of I now greater than a of j? It is. So how you will update it as? You will update it as lis of j plus 1. So here lis of j is 2. So when you will do plus 1, it will become 3, right? So now we have 3 here, right? So in all, it is greater than 3 as well, right? So in this way, what you will do, what you can do is you can just similarly start I from 1 to n, start j from 0 to I, right? Do this comparison whether a of I is greater than a of j or not, right? As you can see, 9 is greater than 3. So what you will do, lis of 2, that is 1. So you will update it with 2, but not. Why? Because we are already having 3 inside it, so we are not going to update it with 2, right? And then again, if you will update it with 7, so 7 is again smaller than 9, so that can be a part of our lis. But then if you'll add it, if you will again get a 3, so you can keep it like this, only 3 only. So in this way, what you can do is I is traversing from 1 to n, j is traversing from 0 to I, and on the basis of this condition, we are updating lis like this. Okay, so that is what this code is doing. And at the end, you will return the maximum element inside your lis. All right. Is the code clear to you now, Ashutosh? And to all of you, if any queries that is still persisting, please let me know it in the chat section. Or else, you're most welcome. We are good to end this session. Alright, guys, thanks for joining. See you all next week with some new concepts. And till then, everyone, keep up doing the hard work, keep on practicing, keep on accessing the GFG portals. We have everything at place for you all. And thanks everyone for joining the session. See you all in the next week's session. Don't forget to join us. Good night, everyone, and take care.